Hey everyone, welcome to homework 2.17. Today we looked more at inverse functions, and so we're going to be going over that in this homework as well. So a table shows the value of a car in thousands of dollars each year after it was purchased. Plot the data values and find a line that fits the data. So this is that line of best fit that we talked about a little bit earlier today. So I'm going to plot 0, 30, be about here. 1, 22.5, be a little bit above here. 2, 19 will be right above here. 3, 16 here. 4, 13.5 is right about there. And then 5, 11.4, this would be 10, 11 would be right about there. Okay, so you can see here that there's not going to be an exact perfect line, but we're going to do our best to go ahead and create a line of best fit. And really, if you notice, this line has kind of a curve to it. This is actually going to be an exponential function. But for the purpose of this activity, it is asking you to write an equation for the linear function based on the line of best fit that gives the value of the car in thousands of dollars when it is t years old. So we're going to go ahead and do our very best to draw a line through those points. All right, so let's try to go ahead and draw this line. Hopefully this works. Do the best that I can. We're again trying to get as many of these points kind of in the realm of this line. That wasn't super great. It's okay. And so then we're going to write a linear function based on, write an equation based on this line. So this line is starting at like 27 something-ish. So we'll say c of t, that's our function, equals, we're starting with a y-intercept of about 27.5, we'll say. And then notice this is going down. So our slope is definitely going to be negative. And if we go down from here to here, for example, and we create our triangle here, we're going down, it looks like from 27 to like 23.5 maybe or so. So we're going down about 3.5 per year, all right? So this is, again, giving the value in thousands of dollars, so that would be down $3,500 approximately per year. So what does a C of 6 mean in this situation? So this means the value of the car after 6 years. Of course, it decides to do this now. Okay, apparently I can't erase that. After 6 years, okay? And it is going down, so maybe that arrow is appropriate. And then if we put C of 6 in here, we'll do negative 3.5 times 6 plus 27.5 and calculate that. You'll get 6.5. All right, and so 6.5 means that when the car is 6 years old, the car, this is in thousands, is $6,500. That's how much it's worth. So cars, after you purchase them, generally depreciate in value. That trend has changed a little bit over time as certain chips have become available, but right now, generally speaking, as a car gets older, it's no longer worth as much as it was. All right, in this situation, what does the solution to the equation C of t equal 2 tell us? So this is when the cost of the car, the value of the car, is $2,000, and the input for t would tell us at what time that is true. And so to find that, we're going to make 2,000, or remember we're doing this in in thousands. So 2,000 equals negative 3.5t plus 27.5. We can solve by subtracting 27.5 on both sides, and then dividing by negative 3.5. So what will happen on this side is this will cancel out. 2 minus 27.5 is going to give us negative 25.5 equals negative 3.5t. That looks great because we have two negatives, so we know that our answer will be positive. And if we divide both sides by negative 3.5, we get 7.2 28.5, so approximately this. So this means that it's going to take more than 7 years for the car to reach the value of $2,000. And again, a key point here is that I wrote this as 2, not as 2,000, because the values are in thousands. All right, it says write an equation that would allow us to find the age of the car when we know C of t. So C of t equals negative 3.5t plus 27.5. We're going to use our inverse operations here to solve for t. So this will cancel out. I'm going to write here, we'll then get C of t minus 27.5 equals negative 3.5t. Divide both sides by negative 3.5. And we'll get t equals C of t minus 27.5 over negative 3.5. And then it says use your equation to estimate the vehicle age when the value of the car is 500. So the time, or how old the car is, would be 500 minus 27.5 all over negative 3.5. Now here, something I have to be careful about is I wrote 500 here. Remember, we're looking at that value in thousands. So 500 in thousands is really 0.5. So we would do 0.5 minus 27.5, which is going to give us just negative 27 divided by negative 3.5. And that will give us t equals 7.7. So it's even more, right? That is going to take us longer to get to 500 sometime in the 7th year. All right, here, I don't know what's going on with the video. All right, here we go. So number 2, the distance d in kilometers that a car travels at a speed of 80 kilometers per hour for t is given by this equation. If the car has gone 120 kilometers, how long has it been traveling? So we would replace d with 120 equals 80 divided by, or times t. See, my brain's already moving ahead. We're going to divide both sides by 80. And so if we do that, we get t equals 120 divided by 80. So t equals 1.5, and so that's 1.5 hours. It says rewrite the equation to express time as a function of d, and so now we're going to write d equals 80 times t, and we're going to write the inverse of this function. We will get t equals d divided by 80. All right, moving on to number 3. We're matching these to the inverse, so we want to see that what is connected to the inverse of this. So to get the inverse of this, we'd solve for x, so we'd add 3 on both sides and then divide by 2. So we should have y plus 3 divided by 2, and so that would be number 2 right here. For this one right here, we would divide by 3, so we would get x equals y divided by 3. That one's this one right here. Here I'm going to add 2 to both sides and then divide by 3, so that would be that one there. We're adding 2 and then dividing by 3. Here I'm simply adding 2 to both sides, so we should have y plus 2. And then here I'm subtracting 2 from both sides, so we'll have y minus 2. And then lastly here, this is the most complex one. You can probably process of elimination, figure that out. But we're first going to multiply everything by 3. We'll get 3y equals x minus 2. 3 divided by 3 is 1, so that's how that cancels out. And then I'm going to add 2 to both sides, so we'll get 3y plus 2 as the inverse of this one here. That's, oh, that did a whole lot. Okay, there we go. All right, moved out a little bit down, more than I wanted to, but it's what it is. All right, so functions h and j are inverses. When x is negative 10, the value of h of x is 7. So this would give us a point of negative 10 comma 7, and then it asks what is the value of j of 7. So because these are inverses, we know that the value of that, j of 7, would equal negative 10, the opposite or inverse of what we see in the first equation, or the first function. It's to determine if each point is on h, j, or neither. So if negative 10 comma, I keep saying negative 10. Negative 10 comma 7 is in this one, right? That is the function h. And then this is the inverse of this. And so that means this would be on j. And they are opposite of each other, right? Because this x value is the y value here, and this x value is the y value in the second one. All right, number 5. Crickets make chirping sounds by rubbing their wings together. The number of chirps they make is closely related to the temperature. When the temperature is between 55 and 100 degrees Fahrenheit, we can tell the temperature by counting the number of chirps. Okay, a formula that is commonly used to find the temperature in degrees Fahrenheit is the number of chirps per second in 14 seconds, and then adding 40 to the temperature. So they count within 14 seconds how many times do they chirp, and then adding 40. Let n be the number of chirps they make in 14 seconds, and f be the temperature in degrees Fahrenheit. What is the temperature when a cricket chirps 52 times in 14 seconds? So we would take 52, add 40 plus 40 equals 92 times. Or, I'm sorry, 92. So 92 degrees is the temperature in Fahrenheit. Write an equation that defines f as a function of n. So the degrees equal n plus 40. And then how many chirps should we expect to hear in 14 seconds? Again, we're just talking about this 14 seconds when it is 60 degrees Fahrenheit. And so this would be the opposite. We have Fahrenheit equals n plus 40. So this would be 60 equals n plus 40. And that means n equals 20. So 20 times. Write an equation that defines n as a function of f. So our earlier equation with f as a function of n is this. To do the opposite, we'll subtract from both sides and get n equals f minus 40. All right. Number 6, describe the domain and range of the function this graph represents. So for the domain, we're looking at what are the possible x values that we can have here. And so here, x is greater than or equal to, that looks like negative 5. And then there's spaces where it is not equal to a value in x. And so like right here, for example, it is not equal to a value of x. And so we would have to say it's between or less than 3, negative 3. And then x is greater than negative 3 or all the way up to here, less than 6. And then from here to here, x is greater than 6 and less than or equal to 10. So you have to write the domain here in 3 parts because there are parts of the x axis that are not included on this graph. And then the range, our y values, are ranging from here to here. And notice here, there is a space here, right? But there are other points that equal 4 here. Same thing, there's a space where the circle is, but there are other points that equal negative 2. So y here is going to be less than or equal to 4 because there are places where y equals 4 and greater than or equal to negative 2 because again, there are places where it equals negative 2. And then all those spaces in between are on this line. All right, number 7, the parking rate R for a car in a garage is a function of T, the hours it is parked. So T is the input, R is the parking rate, how much it costs. So R of 1 for 1 hour is actually free. For 4.5 hours, we're looking between 4 and 5, so that would be $6. And then R of 8 is greater than 7, so this would be $8. All right. Now it says, here are the rules that define this function, draw the graph of f. So y equals 2 between negative 5 and positive 1. So we're going to look at 2 between negative 5, and these are greater than or equal to here, so they're going to be included in the points. And then I'm just going to simply connect the dots. Now we have a line of x, which means it is a slope of 1 over 1, starting with 1 and going to 5. But notice that these should be open circles here because they are greater than. So here, when I plug in 1 for x, I get 1. So 1 comma 1 is one of my points. And then here, if I plug in 5, I get 5 comma 5 as my other point. So 1, 1 is here, and it's going to be an open circle. And then 5, 5 is here. It's going to be an open circle. And then I can simply connect these points. And notice this is going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And it would cross through the origin. But I'm only looking at the spaces between 1 and 5 on the x-axis. And then lastly, I have 7. So that is going to be from 5, and it's a closed circle, to 7. These are closed circles because we have this or equal to part here. And the value is, oh, I put it on 6, so that's a little bit. I'm going to move it up a little. So I'm going to move it to 7, filling in the circles here from 5 to 7. It is a y value of 7, and so I'm going to fill in that line between it. All right, so that is your piecewise function on the graph. That is it for your homework, and we got through all of our classwork today. So if you didn't and you have questions, you can definitely reach out to me, but otherwise that is it for today. Your code word for today will be grasshopper. Grasshopper is your code word because we talked about crickets in the 6th grade class, and I had a very interesting conversation about grasshoppers. Happy homeworking, and I will see you Monday.